Hello, welcome back to Project Mastery Podcast. We're going to learn about terminologies related to model operationalization. Let us understand what we mean by inference. Inference means we're going to take the model and apply it to new data. We're going to apply the model to new data, which is real world data. The infrastructure is going to be different for inference when compared to training. We do not require GPUs in inference phase. The data pipelines are also going to be different from training, especially for inference phase. We should continue to understand what are the accuracy levels, performance levels, and we should measure them. In case real world data is not matching the model, we need to understand what is model drift, what is data drift. We should find techniques, methods, and means which will result in optimization of different thresholds, namely accuracy, efficiency, and performance. These are the thoughts or the questions that you need to think about when it comes to inference phase. When we say operationalize, what does it mean? When we say we're going to operationalize AI, what does it mean? It means we're going to put all the machine learning models into production environment, meaning real world environment. There are only two phases for ML models. It's going to be training phase, it's going to be inference phase. A model that is built for inference is going to be placed in any location that the model needs to provide predictions. It can be deployed in a mobile application. It can be deployed on a server. The model can reside on cloud. The model can reside as a web browser JavaScript. The model can be deployed on the desktop. It can also be available and deployed on edge device. Deployment is all about putting the model into different locations where it can be operational, meaning it is able to infer on real data. When we talk about model deployment, we need to understand the deployment modes. Do we need to deploy them as a batch process? What is the requirement here? Do I need to generate predictions for the real world data in a time-phased manner, in a regularly scheduled manner, or is it going to be one time? Batch mode predictions will not produce real-time results. You can use them when you want to make decisions which can be done at a later stage. If you don't want the decisions to be made right away, then you don't go with batch prediction. Batch mode systems generally operate offline. They are going to utilize less power, and these batch mode systems don't have to be always connected to a network to provide inference. Microservices are on demand. It's an architecture for computers where you're able to break large concepts of computing functionalities into smaller individual functionalities that can respond. Scalability is very much possible when you use microservice approach. Systems are more reliable here and you're able to quickly develop and add features. Microservices is a means to operationalize models where you are able to provide access to the model inference to any user in the world who can query the microservice by providing the right data inputs, allowing for access to inference which is on demand. Real-time prediction means operationalization of the ML model which is going to operate on a data at the time when the user is expecting some prediction response. Real-time production systems or real-time prediction systems are expected to provide response within seconds, within milliseconds, to perform an action or display the outcome. Example, facial recognition. Example, conversation systems. Example, voice assistants. Let us say loan making decisions, or you're trying to detect some flaws in payment systems, or any other application that's going to operate properly by performing a single prediction operation rather than predicting it at a later time like the batch process. Stream learning is an approach that's going to use real-time data to make model predictions. It is also similar to real-time prediction. Stream learning is expected to make individual rapid predictions on data immediately as quickly, but it might be used downstream by other computer systems rather than providing the outcome to the user. Hence, stream predictions can appear as an alternative for the on-demand service, which is the microservice, since the predictions are being made as part of a different operation or a different activity on the server. There's no need to make additional calls. Cold path analytics is an approach where you want to provide the outcomes after analyzing the data that focus on batch mode operation, where the priority is going to be on accuracy over speed. Hence, it is more useful for reporting analysis and operation use. The processing happens, the result of the processing is going to be stored as a batch view. This is more useful for long-term data storage. It is also used for consuming analytics and predominantly used in batch processing, which needs to be performed on the data. Hot path analytics is just the opposite of this approach, where it is going to provide outcomes by analyzing the data, and once it completes the data analysis operation, it is going to focus on speed over accuracy, and it always refers to real-time prediction on data which is getting streamed, real-time responses when the user is interacting with the application, real-time alerts, real-time streaming operations on data are examples here. Service-oriented architectures have been in place for a long time. Model deployment can also happen as a microservice. You can leverage Amazon Lambda serverless movements. ML operationalization or ML inference can be easily done with microservice architecture, where you're going to pay on demand based on the API call request. Let's talk about on-premise. What is on-premise here? The machine learning infrastructure has got specific elements like development, operations. All these assume that they're going to be hosted and managed by the organization on their own network, and they're going to have their own hardware as opposed to an environment like cloud or a device like edge device. This is one of the most fundamental way to operationalize a model, where you're going to place the model on a computer device. GPUs are required for training, they're not necessarily required for inference. When do we use on-premise models? Machine learning models can be placed on laptop, they can be placed on organization servers, especially when your priority is going to be on batch mode or priority is going to be an offline mode of operationalization, or you want to do a proof of concept, or you want to utilize the model only for testing. There are many situations or circumstances where you want to keep a machine learning model as part of the network related to corporate. ML model is going to be placed in corporate network when you want to focus on security, data access, deliverability, system integration, and especially response time. When do we use on-premise models? We want to use on-premise models when we prefer regulated environments, when we prefer high reliability, when we want the environments to be highly secured, when we want proximity to interface data, or when we want the models to integrate with internal workflows, when we want the models to integrate with process flows. On-premise, or we can call it as on your machine, is not a costly affair. The limitation is it's not going to scale easily. Scalability is always a challenge here, and there will be downtime as it's always subject to system availability. Edge device is a device, it's a hardware that will act as an endpoint on a particular network. It can be sensors, it can be mobile phones, it can be cameras, or any other device, but it's going to have a limited bandwidth, it will have a limited storage, it will have limited computing ability. They can operate in offline or sometimes get connected with high speed on the device. Edge devices don't need to be complicated to inference on models. In embedded devices, we can take the example of intelligent camera, voice assistant, other security systems. There are specialist hardwares available for edge model inference, specifically, example, NVIDIA, Raspberry, and other AI chips. We can use the cloud environment or the online cloud environment, which is hosted and managed by different third-party providers. There are various elements of machine learning, especially development operations. You want to move your model to cloud, it will definitely make sense if the data is going to be also in cloud and the access to the model has to be on demand or real time, then it's better to go with cloud environment approach. If the requirement is location agnostic, it's better to host the model on cloud. Cloud machine learning providers provide easy scalability. Machine learning as a service means there are cloud-based solutions available for machine learning. There are many machine learning services available where you need to pre-process data. We're talking about model development, we're talking about model training, there is model inference, there is model evaluation, model governance is there, model operationalization, we're talking about pre-trained models. There are many capabilities, and all of these capabilities can be provided as cloud-based solutions. Then this is what we call it as machine learning as a service. You can operationalize machine learning at the edge. You can implement the models on edge devices or any computer system that doesn't require connectivity, like mobile devices, on desktop, on embedded devices, or in browsers. The tools that you're going to use to build the edge models must support the edge devices you want to use. You can operate the AI on-premise. As I spoke earlier, machine learning models can be operationalized on enterprise servers. They can be implemented in integration middleware. They can also be implemented in enterprise applications. Microservices can also be used by other applications on a network which is local. Machine learning models can be shared across the enterprise. Machine learning models can be operationalized in on-premise server environments. Cloud ML. We have the online cloud environment which is hosted by third-party provider, and it is going to provide cloud-based solution for many aspects of machine learning related to development and operations. You can use the cloud to train a model, operationalize a model, and for all the aspects related to data engineering. You can move your model to cloud. When you move to cloud, you should always keep in mind there are privacy, security, regulatory obligations that we must meet. There are complexity issues that will arise when you use cloud. We should proactively address these issues. You don't have to deploy everything on cloud. There are different options for deployment here. You can use the cloud for training purpose alone. You want to train the model on cloud, you can also host the model on-premise. GPUs are expensive, training does not require as often GPUs like inference. You can accelerate the training process. You can move your trained model on-premise. Training data needs to be in the cloud is the biggest challenge here. You can use the cloud to host your model, which is a different option. Meaning, just like we spoke about how you can use the cloud for training purpose. In this option, you can train your model locally and use the cloud to host your model. You are going to pay only for the compute charges when you use the model. Better scalability, better availability. Training data can be kept private on your own network. When it comes to edge devices should be able to access the cloud hosted model, which is an important point here. We spoke about hosting on cloud only for training purpose. We spoke about hosting the model on cloud and training it locally. Or you want to use the cloud for everything, that's also an option where you're going to use the cloud to both train the model as well as host the model. You can leverage cloud-based third-party services. You can leverage cloud-based third-party models. Cloud is going to do everything for you. You're going to pay just the cloud cost. Training data can be hosted on the cloud. You can use cloud GPUs for training. Model lifecycle management refers to different development process and artifacts. There are training datasets, there are test datasets, there are validation datasets, there are hyperparameter configurations. We're talking about ensemble models. We're talking about how do you manage these ensemble models. What are the hyperparameter configurations and settings that we need to manage. All these are artifacts. You need to manage the retraining pipelines. You need to find out what are the model deployment requirements. Are you going to deploy it on a single device or on-premise, or are you going to deploy it on edge or a server or a cloud, or what are the other operation requirements where you want to follow which kind of mode here. Are you going to follow the batch mode? Are you going to follow real-time mode? Is the usage going to be on demand? What are the scaling requirements here? These are the model deployment needs. We also need to think about model versioning when it comes to model lifecycle management. How do you handle model versioning? How are you going to communicate these to the model consumers? Machine learning operation refers to a particular approach in the lifecycle of machine learning where you will have both tools and methods available that will make sure that the models are able to provide the results at the acceptable performance level. There are two major components here. One is the DevOps for ML, where you talk about model deployment, model versioning, model development lifecycle, and IT ops. There are model specific ops. Example, you want to measure model drift, you want to measure data drift, you want to manage them, you want to establish data provenance, you want to establish data governance, you want to establish model governance. There is also model discovery. All these are the aspects that come under model specific ops. Data lifecycle refers to different aspects. Managing data lifecycle is going to be as important as managing the lifecycle of a model. You need to understand how the data is being generated. You need to understand how the data is being collected. Once it's collected, you need to understand how the data is being stored. The data needs to be accessed. So how is the data accessed? The data needs to be used. How is the data being used? The data needs to be transferred. How is it being transferred? The data has to be secured. How is the data being secured? Data needs to be archived for long-term storage. How is the data being archived? The data needs to be deleted or destroyed if there is a requirement. How is the data deleted or destroyed? What are the data privacy requirements? What are the data policy requirements? What are the regulatory requirements? All these are the aspects related to data lifecycle. Collecting, storing, training data, collecting, storing, inference data with high quality, tracking data drift, tracking model drift, storage of model configuration data, data fairness, challenges in dealing with edge device data. Data has to be moved from the cloud, has to be moved into the cloud. So how do you handle these data challenges? These are the AI considerations when it comes to data lifecycle. We have covered all the terminologies related to machine learning model operationalization. We will cover the remaining concepts related to model operation phase in part 2. We have come to the end of the podcast. The knowledge is valuable. Thank you for tuning in.